Hello everyone, welcome to the video. Today I'm going to show you how to use the 74HC595 shift register. In this video we will be making a binary counter to demonstrate and show you how to use it. And I'll be showing you other things as well. So without further ado, let's get started. And so first, I'm going to go ahead and explain the chip, and as you can see, we have all these pins right here. So basically right here, as you see, we have Q1, Q2, Q3, and all the way up to Q7 right here. These are all the output pins, including pin 15 on the chip as well, which is included. It's just on the other side. It's actually the first pin, so it's before pin 1. And all these pins are the output pins that you will connect to your display. If that's your LED display, or 8-segment display, or whatever display you are using. And so these are the pins that we will be using. And then we'll go ahead and explain all these other pins. I'm going to skip some of them because we know what G and D is. I'm not going to explain this one because we're not using it, and this one is just connected to ground, this pin, which is all M, which is pin 10 on here, and pin 8 is ground, pin 9 is a pin that we're not using, and then we have pin 11, which is shift register clock pin. This pin is used for the Arduino and the chip to communicate with each other. And so then the next pin here is pin 12. This is basically called the latch pin, which we turn it low whenever the Arduino is sending bytes to the shift register. So whenever we send it high, then the shift register knows that it's not receiving any information. And then the next pin on the chip is 13, and this pin is output enable active low. So basically it's just telling us if the output should be enabled, and it tells us when it's low, that means it's active, it's currently working. And so we also connect this to ground. And then we have the DS pin, which is pin 14 on the shift register, and so it's right here, and this is the serial input. And so basically this is where the data is going to be sent to the chip right here. And then we have a VCC right here, which is where positive 5 volts is connected to the chip, so the chip can get power. And so basically that is how you connect up the shift register. And so now we'll go ahead and connect up the circuit. Okay, so now we'll go ahead and connect up the circuit. And as you can see, I already have it installed right here, and I've also connected some of these wires up to it already because they take some time to put in. So I decided just to do that off camera. But I have not added any components to it but the shift register. So the shift register, as you can see, all of the pins, all the output pins are connected over here, and which then will be connected to the resistors, and then through the resistors the LEDs will be connected, which then all the grounds of the LEDs are over here, as you can see, all connected to ground rail right here. And so basically pin 8 right here is connected to ground, as you can see, which then we will soon connect to the Arduino Mega. You can use any type of Arduino, you can use the Arduino Uno, any type, doesn't matter, but in this case I'm using the Arduino Mega. And then we come over here, we skip pin 9 and we go to pin 10. This pin will be connected to 5 volts. And then we skip all the way to pin 13 on the chip, and this is going to be connected to G and D. Then we go all the way up to pin 16. This pin will be connected to 5 volts. And then also we have connected pin 15, which is actually digital output 0. So it's the first pin of the row of pins over here. It's just over here for some reason, so I connected it over here, which then we will connect the resistors to. So now we'll go ahead and connect this up to the Arduino. So first I'm going to go ahead and connect the power pins. So G and D on the Arduino will be connected to the ground rail, so everything has ground. And then I'm going to connect the 5V pin, which provides positive 5 volts. Connect that to the positive rail on the breadboard. Then we're going to go ahead and connect pin 14 of the shift register to pin 11 on the Arduino. So there we go. And then this pin right here will be connected to digital pin 8. This is pin 12 on the shift register. It will be connected to pin 8 on the Arduino. So we'll go ahead and connect that. And then pin 11 on the shift register will be connected to pin 12 on the Arduino. And so basically that is how we connect it to the Arduino. Now we'll go ahead and add all the LEDs. Okay, Okay, there are all the LEDs. Now I'll go ahead and connect them to their resistors. Remember that this LED is the first LED, and it will be connected to pin 15 on the chip right here, and then so on for 1, 2, 3, and all the way over here to pin 7 to this LED. So on, all in order. And so there you go, that should be the whole circuit. And so now I'll go ahead and show you how to use the shift register and also build a counter with a binary counter with it. Okay, so now here is the code for our binary counter. And so all we do is we define latch pin, which is connected to pin 8, so we put that into the variable. And then we have clock pin, we set that variable up, and we put a 12 in that variable because the clock pin is connected to pin 12. And we have data pin, which is pin 11, because we connected the latch pin to pin 11. And so basically now we go into the void loop, and we have a full loop. And so basically what we're going to do in here is we're just going to increment number to display, which is right away, right when we come in here, is equal to 0. That's why we have this part right here. And we have number to display is less than 256. As long as this is less than this number, then we can continue coming into this for loop and continue incrementing as we do here, number to display. Now you may be wondering, okay, well, what is this thing? Well, whenever you give a number between 0 and 255, the Arduino will put that into binary, which is basically the information that the Arduino will be sending to the shift register. And in binary, that will tell the shift register which LEDs need to be turned on. And so I'll show you more about this in a few minutes. So now the next thing we do here is we go ahead and digital write latch pin low, because we're going to send information to the shift register. We want to go ahead and send that pin low. So that's what we do. We do digital write and send latch pin low. And then we do shift out, which tells the Arduino that it's going to be sending information to the shift register. And we say what pin the data pin is connected to, which is the pin that is going to be sending the data to the shift register. And then we're going to give it clock pin so that the Arduino and the shift register know what to do with this information and things like that. And then we have this right here, which is LS, which means least byte first. So basically what this is just telling us which direction we want these bytes to go in. If we want them to go in one way or another way. So basically, in both ways, the bytes can go into either way. Because all it is basically, for example, we can set 1, 2, 3, 4, 5, 6, 7, 8. It's basically giving us these numbers right here, 0, 0, 0, which means all the LEDs are going to be off. And we've given 1, then this becomes binary as we put 1s and 0s in here. This number can be flipped, and that depends on what direction your display will be counting. It could be just counting left, or it could be counting right. And so basically that is what that's doing. And it doesn't really matter, because all you can do is if you want to switch it to the next direction, if you want it to count the other way, then you go ahead and just do M. That would flip the other direction. But we're just going to go with this. It doesn't really matter, really. Just that tells us the direction. And then we have number to display. This is going to be holding our number that will be in between 0 and 255. And this number is incrementing every single time we loop this full loop, so it's going to be slowly going up until it reaches 255. After that, it will repeat, restart again. And then after that, we're just going to go ahead and turn latch pin high, saying that we're done sending this information. And then we just delay 500 milliseconds. And so basically that is the code. So now we can go and see how this binary counter is working, and then we'll come back and I'll explain a few more things. Okay, so now here is the project, and as you can see, we have a binary counter right here. It's counting one by one, and it's going all the way up to max, to where all the LEDs are going to be on. So now let's go back to the code and I'll show you more. Okay, so now here we are, we're back again, and I've changed a few things with the code. I basically took out the for loop because we're not going to be counting, having a binary counter anymore, because I just want to show you something real quick, and that is giving the chip itself binary. Because basically what this is doing, the shift out pin, is basically converting it into binary, but here we're just giving it binary already, so it doesn't really have to convert binary. And so basically this is it right here. We have OB, which tells that this value is binary. This right here is the actual binary number. And if you can see it above me, this is actually what this binary number is giving us. And as you can see, it's kind of interesting. 2 LEDs on the side, on both sides, all lit, and all the other ones are off. And that's the same thing we have here. We have 1 on each side of this number. And after that, all the other numbers are 0. Each one of these numbers refers to each one of these pins. And so basically you can see that maybe pin 15 on the shift register would belong here, a number right here, which is 1, which means pin 15 on the shift register is on. And then this maybe is for pin 1, and then pin 2, and then pin 3, and then pin 4, and then pin 5, and so on. And that's what each one in order these numbers are representing. We can have this, and then we get this above, as you can see. And so basically that is how you could use this without even having to use like a number or something like that. Just punching the number in between 0 and 255, you can actually use binary as well. And so basically that is how you use the shift register with Arduino. And so if you like this video, guys, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you, everyone. Have a great day. Bye.